because Anthony wouldn't do that. All right, class. You guys don't sound excited. You don't. So let's pretend like you already had 40 ounces of coffee at this current moment in time. So let's start there. So class.
Yes.
Okay, a little bit better, a little bit better. Okay, so 4.2, we are second day on this, and let's pretend like I was a student that missed yesterday's lesson. What should that person try to do? Do they have the notes? I have no clue where the notes went. Anyone recall where those notes went? Right there? Are they right there? Yeah, there we go. Okay. All right, I think this is going to clear up a lot of the issues that we were having with the parentheses and brackets and all that other stuff. So, right here, extreme value theorem. So if a function is continuous, right, continuous on a closed interval, that's brackets, then f has an absolute maximum and an absolute minimum. Right? Okay. So if it's continuous and I'm looking for absolute, okay, it's got to be closed interval. You notice it doesn't say on open interval. Okay, local. If a function has a local maximum or a local minimum at a number c, then f prime of c is equal to 0. Or f prime of c does not exist. Now, I'm going to draw an upside down parabola. My maximum is right there, right? What's the slope at that point? Slope is going to be 0. That's like the big takeaway from all of this. The slope is going to be 0 at this point right here. And that's going to be a minimum or maximum. So regular parabola, right here, again, slope was 0. What about that right there? That has a slope of 0, right? Okay, it has a slope of 0, but does that mean that that's a minimum or a maximum? No. So it doesn't always apply, but when we have this, we have to start checking our numbers to see in relation to the rest of my problems. If a differentiable function has a local maximum or a local minimum at c, then f prime of c is equal to 0. Now, if I could take a derivative, let's go back to our definition. For the derivative, what has to happen? Let's go all the way back to unit 1. Very good. Limit as x approaches whatever my c value from the left is equal to the limit as x approaches the c value from the right, which is equal to the function of f of c. All those things must be equal, or derivative's got to work. So left side, right side. So can I have a local at an endpoint? No. That was what we were talking about yesterday. So we're not going to have a local at an endpoint. Critical numbers. A number of function f is a number c in the domain for which that either f prime of c is equal to 0 or f prime of c does not exist. So, now, what does f prime mean? F prime, it means I have what? The what? The derivative, right? The derivative. So, think about this carefully. Derivative. Can I take a derivative at this point? No, that's a cusp. This one's a corner. But same concept. It's one of those pointy points. So I can't take a derivative at that point, but does that meet this criteria now? The derivative does not exist at those points, but it still can be one of my critical points here. And then right here, that one right there, my derivative is equal to 0, so that means that's going to be at least a local. Blade, you had a question? That's what we're actually talking about right now. These are all critical points. These are points in which that, yeah, we're going to get all those. So we're eventually going to get into the points of not just those, but we're also going to get into flexion points later on, and when we're dealing with concavity. So when we're getting to that. So these are going to be my critical numbers here. So critical number there, critical number there. Right here, my derivative is equal to 0. That is a critical number, but it might not apply to mins and maxes. Like that right there. Critical number right there, that is my corner right there. And let's see. I'm going to pick this up tomorrow. Yeah. Because we actually have 4 days on this lesson, and we only have like 3 more slides left of this. Like I said, this is mainly definitions today. So I'm hoping you guys are actually doing the 4.2 homework. Otherwise, you're really going to be struggling, you know, every day for this. I don't want you guys struggling. So you have a lot of time in class right now to work on 4.2. Please don't be that person that's actually only doing 4.1.